Welcome to the Product Design Show. I'm Vince Penman. 10 years ago, electronics were a product category all on their own.
Now electronics are integrated into nearly everything. In this video, we'll explore how design teams are incorporating electronics into their new products. I'm Allison Tupperwine. These days, a fridge has to be more than a fridge. It's got to deliver precisely chilled water and tell you about the local forecast, all while maintaining its original function of keeping your groceries cold.
Designing these electronics-loaded products isn't just about filling them full of sensors or sticking a Wi-Fi antenna on the top. Designers have a lot to consider, particularly when it comes to the hows and wheres of electronic features.
Members of the design team will have to plan how the user will interact with the core systems of the appliance through this new interface, while also considering how an electronic addition will fit within an existing system.
Complicating this planning is that multidisciplinary teams have to effectively communicate as they iterate through design ideas. For example, any change to the electronics may also affect the software and mechanical design.
One way that engineers work through this issue is to use design environment systems that allow easy ECAD and MCAD model sharing.
By using a flexible design environment, electronics designers, mechanical designers, software engineers, and industrial designers can use a top-down approach to more effectively guide a product's development.
For example, this fridge has all the capabilities of a smartphone, and that means it's going to need all of the chips, resistors, capacitors, and other components that you'd find in a phone.
But unlike a cell phone, which hopefully stays in a relatively dry environment, fridge electronics have to be insulated from moisture.
By using an integrated ECAD-MCAD system, a design team iterating the dimensions of the electronics can nail down the dimensions of a PCB early in the product design phase.
This envelope can then be used by both the mechanical designers to shape the interior insulation and by the industrial design team to finalize the form factors for the electronics interface.
Another place where strong ECAD-MCAD collaboration is useful is when a design has to be updated. Let's use a cell phone as an example.
Say the design team wants to create a phone with a larger display while making the overall product thinner.
Those two potentially conflicting design goals can lead a team to waste a ton of time working through numerous design iterations that can't house the needed electronics.
To prevent this from happening, everyone on a team has to be able to design within a framework that allows for strong and structured collaboration. And that's exactly what you get by using a robust ECAD-MCAD collaboration software.
This episode is sponsored by PTC. To learn more about PTC Creo's ECAD-MCAD collaboration extension and how it can help your team develop products, visit ptc.com/product/Creo/ECAD-MCAD collaboration extension.
And thanks for watching this episode of the Product Design Show. Please give it a like on Facebook, subscribe on YouTube, or give us a rating on iTunes.